Hello friends, today we will study density in ship stability. Okay, so our topic today is density, relative density, effect of temperature on density. Okay, and how to find volume, mass with density. Okay, and some problems. Okay, so what is density? Before I go to density, let's give you a simple example. So assume that you have 1 kg of steel ball in your hand, and you have 1 kg of cotton. Okay, so if we keep both on a table, or let's say on a box, okay, which object need more space? Okay, obviously the 1 kg of steel ball is a small ball, so it will occupy less space, but the cotton is uh, cotton needs bigger space, correct? So when we what is the why is it taking why the cotton is taking more space and why the steel ball is taking less space? So that fundamentally is explained by the density. Okay, so from this example only we can find out how the density is derived. Okay, so by density is the volume sorry density is the mass of an object in unit volume. Okay, so what it means is, for a unit volume of space, how much mass an object possess. Okay, that means let's assume this entire box is 1 metric cubes. Okay, so to fill this entire 1 cubics of 1 cubics volume of box, how much weight of cotton is required, and how much weight of steel ball is required? So that is the derivation of the density. So in layman's language, we say density is equal to mass by volume. Okay, so the SI unit of mass is tons and volume is metric cubes. So the unit of density will be tons per metric cube. Okay, so if I say the density of steel, let's say example 1.0 9 tons per metric cube. That means, what does it means? If in a 1 metric cube box we can fill total weight of 1.9 tons of steel. Okay, so that is the meaning of the meaning and derivation of density. Okay. Now let's work out some example. Okay, there is a tank. Okay, a tank has a volume of 400 cubics. Okay, and we need to fill that tank with salt water. Okay, salt water, and we want to find out, after filling the tank, what will be the weight of the tank, or what will be the weight of the salt water inside the tank. Okay, so there is a tank and their volume is 400 cubics. Okay, so we want to press up all the tank with the salt water. So we have the volume here, and we want to find the weight of the salt water inside the tank. So what we have is density. Density is equal to mass divided by volume. Okay, so volume we have, that is 400 meter cubes. Okay, density, that also we have, salt water density is 1.025. Okay, so that is 1.025. Okay, so what we want to find out is weight. Okay, so 1.025 is equal to mass divided by 400. Okay, mass is equal to 1.025 into 400, that is 410 tons of salt water. Okay, this is one example of density problem. Now another topic is relative density. So by definition, relative density is, or relative density of a substance is the number of times the substance is heavier than fresh water. Okay, so the freshwater density is considered as 1.0. Okay, so if you say the relative density of a substance, that means let's say an object, and it is having a density, it's have its own density, its own mass by volume. Okay, so this density, when we compare the density of this thing with the freshwater density, okay, that is called the relative density. So it is compared in such a way that how much times the density of the substance, this density of this substance is how much heavier than the density of fresh water. So the relative density from the derivation, we can come to a formula. Relative density is equal to actual density of substance, that is this one, the density of the substance, its own density, divided by density of fresh water. Okay, so we know the density of fresh water is density is 1, okay, 1.0. okay, so it is when we come to a ratio and find out the relative density, it is numerically comes to the same value. Okay, for let's example, a density of a object is 0.8 tons per meter cube. Okay, so the relative density of that object is its own density, that is 0.8 tons per meter cube, divided by the density of fresh water, that is 1.0 tons per meter cube. The interesting part is this is a ratio of two densities, so that when you do the ratios, this when you compare two ratios, the unit will get cancelled each other. Okay, and you will get just a number 0.8 by 1, that is 0.8. So the relative density have no units. Okay, now let's do an exercise. So there is a tank. Can hold around 320 tons of salt water. Okay, so in this tank we want to load oil. Okay, oil, and its density is 0.8. okay, you can say relative density, let's say for the same. Okay, it can, so we want to load oil inside the tank, and density of the oil is 0.8. okay, so we want to find out how much will be the weight of the oil in the tank. Okay, so let's assume this is our tank. Okay, this entire tank can hold seawater. Okay, when the tank is fully filled, the weight of the seawater inside the tank will be 320 tons. So in the same tank you want to load oil. Okay, oil. So if you are loading oil, what would be the weight? Okay, so what all the to find out this thing, let's go to a steps. Okay, so what we have here, oil and its density. Okay, density we have, okay, 0.8. What is the formula of density? Mass by volume. Okay, volume means volume of the tank. Okay, mass means mass of the oil. Okay, this mass of the oil that we need to find out here. Okay, so this, what else we have here? Volume. How in the question the volume of the tank is not given, so we have to find the volume using the other information, 320 tons of seawater. Okay, now what is the density of seawater? Is equal to 1.025. Okay, that means mass by volume. Okay, so mass, we know when we fully fill the tank with the seawater, the mass is 320 tons. 320 tons. Okay, volume of the tank, don't know, but the density we know. So from the formula, volume of the tank is equal to 320 divided by 1.025. Correct? So when you do the calculation, we will I don't have the calculator in my hand yet. Okay, so let's assume this much volume, unit of volume is metric cubes. Okay, let's stay this thing here like this. Okay, so the volume will be 312.195 metric cube. Okay, so let's give a number to this answer 1. Now what is our question? Okay, question, we want to find out the weight of the oil inside the tank when it is fully filled. So density of oil is 0.8. Mass we need to find out, volume we already got. Okay, so let's find out the weight of the oil or mass of the oil is equal to volume of oil inside the tank. Correct? That is volume of the tank multiplied by density of oil. What is the volume? Volume, that is this 312.195. 312.195 into density is 0.8. So mass of the oil is equal to 249.8 tons. Okay, so the the tank can hold 249.8 tons of oil, which has density of 0.8. Okay, so this is the answer. This is how we use the density, volume, and find out the mass. Okay, okay, and let's do another question. This is a we have a tank, a rectangular tank. Okay, okay, so this rectangular tank has a dimension. Length is equal to 20 meters. Okay, height is equal to 20 meters. Breadth is equal to, height is equal to 10 meters, breadth is equal to 10 meters. Okay, and this tank has an ullage pipe. Okay, ullage pipe extending 0.5 meter above the tank. Okay, okay, this is 0.5. Okay, this pipe is extending above the tank, 0.5 meter above the tank. Okay, so now the question is, this tank is filled with fresh water. Okay, okay, so only till 98%. Okay, so not full, 2 percentage is empty. Okay, from the top of the tank 2 percentage of the volume is empty. So we need to find out what is the mass of the water when it is filled at 98 percentage, and ullage when tank is 98 percentage. Okay, so mass of the, first we need to find out mass of water. So we know the formula, density is equal to mass by volume. So mass here is equal to volume into density. So fresh water density is 1. Okay, so if we find out the volume of the tank at 98 percentage, then that is the mass of fresh water, right? So we need to find out the volume. Volume of a rectangular tank is equal to length into breadth into height. So we don't need to find out the entire volume of the tank. We only need to find out the level up to which the water is filled. So instead of height, let's write as sounding. Correct? So sounding of water. So length is equal to 20 meters, right? Breadth is equal to 10 meter, and the sounding we, in the question it is stated only 98 percentage of the tank is filled. So 98 percentage of the height. So height is 10 meter. 98 percentage of the height means 9.8 meters. Okay, so the answer will be 1960. Okay, so this is one method, or you can just find out the length into breadth into actual total height of the tank, that is 10 meters. Okay, height, okay, 20 into 10 into 10. Okay, that is the total volume. So this volumes we take 98 percentage of this volume, then also we get the same answer. Okay, now we have the volume of the tank, volume of the water filled inside the tank. Since the density of fresh water is 1, so we know weight of the fresh water is 1960 tons. Okay, and our second part of the question is ullage when tank is 98 percentage full. Okay, so we know the height of the height of the tank is 10 meter. Okay, and sounding of the water is 9.8 meters. So how much would be the ullage? Let me draw in another line page. Okay, this is the top side of the tank. This is the sounding pipe, 0.5 meters height from the tank. Okay, and this is 10 meter height tank. Up to 9.8 meters water is filled. Okay, so remaining is how many? 0.2 meters. Okay, now the ullage means is the height above the liquid is called ullage. Okay, and whatever the height from the liquid surface to bottom of the tank is also called innage. Okay, so we need to find out the ullage. So for measuring the ullage, we use a tape, and that tape is inserted through the ullage pipe, and when the tape reaches the water level, we take the measurement. So what the measurement we are reading is from the top of the ullage pipe. So whenever we say ullage, if ullage pipe is given, then whatever this value and the ullage value has to be added. So here the ullage of the tank is 0.2 meter, that is this value, plus 0.5, that is 0.7 meters. Now let's talk about effects of temperature in density. Okay, so it is simple physics that any liquid, okay, liquid is heated up on a container, it will evaporate and the volume of the object will increase. Okay, so but the weight never change, weight remains same. Okay, so the density is equal to mass by volume. Okay, when a liquid or a substance gets expanded from its original volume, so the volume will increase. Okay, so as in this ratio, if the volume increases, the density will reduce. Okay, the mass of the object will remain constant, only the volume is increasing or decreasing. So how it is, what is this temperature change is considered in ship's cargo planning and other substances. When let's assume in many of the cargo tanks, when the oil is loaded, okay, it have a particular density, loading density. Okay, so when the ship goes to some other cold region or cold warm region, okay, so in cold region temperature comes down. So when the temperature comes down, the oil density will also, the volume of the oil volume will comes down. So the density increases. Okay, when the volume comes down, the density increases, mass remains same, but at the final port, when you come and take the ullage of the oil, there may be 5 to 10 centimeter drop in ullage. So when the port discharge port surveyor comes, he says there is a less cargo, he will create unnecessary problem. So what if something goes, if the ship goes to warm region, in warm region the volume increases. Okay, due to temperature the volume increases. Okay, so what happens, the density will decrease. Okay, so in warm region what happen when the cargo tank is almost full, and due to rise in temperature, what happens, the cargo tank, whatever remain empty space inside the cargo tank, the cargo try to expand through the tank. So what happen, if there is any small opening or something like that, there may be a tendency to leakage of the cargo. So whenever we plan the cargo loading for a cargo tank, okay, so we always keep some allowance, okay, keep allowance in cargo expansion, okay, due to temperature, okay. So that by considering that expansion volume, and we apply it to the density, present density, and we expect the temperature is going to increase, and what would be the expansion, and we consider all those things, and when we leave some space, so the temperature, due to temperature increase in rise, the volume of the cargo will change. That leads to change in density. So another important thing is uh, uh, okay, that I already explained in the cargo loading video. Okay, no, I am not repeating that here. Okay, okay, let's do another question. Okay, so there is a tank, rectangular tank, length is 20 meters, okay, uh, uh, depth is 12 meters, and the breadth is 20 meters, okay, 20 into 20 into 12. So in this tank, we have to load an oil, okay, relative density of the oil is 0.8, okay, and while loading the oil, 2% of the tank volume to be left for expansion, okay. So after the expansion, after loading, how much would be the ullage, okay, if we leave 2% for expansion, and an ullage, if there is an ullage pipe of 0.5 meters after loading this tank, how much will be the ullage, okay. So here what we have to find out is ullage, okay. What we have is relative density and the tank volume, okay, and we need to find out the after leaving 2% for expansion, how much is the weight of oil loaded, okay. Now density is equal to mass by volume. Volume is equal to mass divided by density, okay. Now this is not okay. What we need to find out is weight, okay. So mass is equal to density into volume, okay. So density we have here is 0.8. Volume is equal to length of the tank 20, breadth of the tank 20 into depth of the oil. Okay, that is 2 percentage minus 12 meters. So 2 percentage minus 12 meters is 11.76 meters. Okay, so we get mass of the oil is equal to, we multiply everything and we get mass is equal to 3763.2 tons. Okay, and how much will be the ullage? Another question is ullage. We need to find out the ullage also. Okay, so we know 11.76 meter is the innage of the oil and the ullage will be 0.5 meter plus innage. The innage is 2% of this height, right? So plus 0.24, that is 0.74. Okay.